Hello everyone, welcome back to uLearn Education Online channel. In today's video, we are going to see how to generate an amplitude modulated signal with the help of other method, that is the switching modulator. Okay, so in the previous video we have seen how to generate an amplitude modulated signal using the square law modulator. Now let us recall what are the blocks involved in this square law modulator. So here the blocks involved in the square law modulator is an adder circuit to which the message signal and the carrier signal is applied, and second one is the nonlinear device, and third one is the band pass filter. Okay, thereafter we can get an amplitude modulated signal. By using this same block, we can design the switching modulator circuit. How we can design the switching modulator circuit? Here, by replacing this nonlinear device with some other circuit, we can easily generate an amplitude modulated signal. Okay, so now which device is replaced in the switching modulator? As the name itself indicates that the amplitude modulated signal will generated based on the switch circuit, which means that here the same diode will be used, but it uses the switch action. Okay, switch action means on and off condition. Okay, one particular point the switch will be on, which indicates that the diode is on, indicates it acts as a short circuit. In other point the diode will be off, indicates it acts a open circuit. Okay, so here this diode is acting as a switch element, that's why we are getting the name as a switching modulator circuit. Now let us see what is the block diagram of switching modulator. So here the block diagram of switching modulator is same as that of square law modulator as we seen previous. Here in the square law modulator we are using this nonlinear device, whereas here we are using a diode switch element. Okay, so similar, this is an adder circuit. To this adder circuit, the message signal and the carrier signal that is generated from the local oscillator is applied. Thereafter the added signal is given to the diode switch element. Here this diode will be act as a switch based on this carrier signal. Okay, which means here we have to make assumptions, that is the amplitude of the carrier should be greater than the amplitude of message signal, and also here the diode operation can be controlled only with the help of the carrier signal. Okay, so let us assume one carrier signal as a sinusoidal signal. Okay, so here during this positive cycle or positive half cycle of the carrier, this diode will act as a closed switch. Therefore, I can write as V2 as V1. Okay, whereas during the negative half cycle of the diode, it acts as a open switch. Therefore, I can write the output of diode is 0. If I represented it mathematically, you can easily understand. Okay, now this output of this V2 signal means the diode output is passed through the band pass filter. Now what the filter will do, it just filter out the signals that are out of the frequencies of band pass frequencies. Thereafter the obtained output is an amplitude modulated signal. Now we have to mathematically prove how the signal is generated here is an amplitude modulated signal. Now let us see what is the mathematical analysis of switching modulator circuit. So now let us see what is the output of an adder block. So here this output of an adder is indicated with V1, and it is V1 is value is summation of message and the carrier, that is M of t plus C of t. Now let us write this output of adder value will be, it is indicated with V1, which is equal to M of t plus C of t, where C of t is the signal generated from the local oscillator, and I am assuming that C of t mathematically is AC cos 2 pi fct. Now I can write V1 expression as M of t plus AC into cos 2 pi fct. Okay, now this signal is passed through the diode switch element. Now what the diode will do? It will simply allows the signal at particular point and does not allow the signal at other particular point. Let us assuming that the diode is operated based on this carrier signal frequency, which means that I am assuming this diode is controlled by carrier signal, so the carrier signal is a high frequency signal. Okay, so here it is a positive signal and here it is a negative signal of a carrier signal. I am assuming this as a carrier signal. Now what the diode value will be? I can write the diode output as V2 and it is simply depends on the carrier signal, which means that whenever this carrier signal is greater than 0 or during the positive half cycle of the carrier signal, this diode will be on state and it will act as a short circuit. Okay, so at that case I can write as V2 as V1. Since during the positive half cycle the diode is on, which means it indicates a short circuit, it simply allows the signal to the output path. So it is V2 as V1. Now let us see what happens during the negative half cycle. So during the negative half cycle, this diode will be in off state, okay, which means it acts as an open circuit, which means that it simply blocks the incoming signal. Therefore, I can write the output of a diode value will be equal to 0. Since these conditions or cases are there in the diode switch element, finally I can write the output or the mathematical representation of the output of diode switch element is V1 into x of t. Okay, so this x of t is the condition of a carrier signal. So during the positive half cycle its value is V2 is equal to V1 and during the negative half cycle its value is V2 is equal to 0. Now let us consider that the action of diode is given by the waveform which is represented with the pulse signal, or we can call it as a square wave signal which is not having a negative half cycle. Okay, so this is only positive half cycle will be present and there is no negative half cycle, and its time period I can represent as 1 by fc. Okay, now for this, if you consider the Fourier series of this signal, we can obtain as x of t is equal to 1 by 2 plus 2 by pi sigma n is equal to 1 to infinite minus 1 whole power n minus 1 by 2n minus 1 into cos 2 pi fc into n minus 1 t. Okay, so therefore the output of a diode switch element finally its value is V1 into x of t. Now substitute the value of x of t and also the value of V1 in this expression. Now we will get V2 is equal to V1 expression is m of t plus AC cos 2 pi fct, and what is the x of t expression? Its x of t expression is 1 by 2 plus 2 by pi sigma n is equal to 1 to infinite minus 1 whole power n minus 1 by 2n minus 1 into cos 2 pi fc into 2n minus 1 into t. So this is the value of V2 expression. Now simply do multiplication. We will get 1 by 2 m of t plus 2 by pi sigma n is equal to 1 to infinite minus 1 whole power n minus 1 by 2n minus 1 into cos 2 pi fc into 2n minus 1 into t. Okay, next multiply AC value, we'll get it is 1 by 2 into AC cos 2 pi fct plus 2 by pi into AC cos 2 pi fct sigma n is equal to 1 to infinite minus 1 whole power n minus 1 by 2n minus 1 into cos 2 pi fc into 2n minus 1 into t. So for easy understanding, let us expand these equations up to n is equal to 1 and n is equal to 2. Okay. Therefore, I can write it as 1 by 2 m of t plus 2 by pi. So here m of t value is there. Okay. So it is 2 by pi m of t into. Now let us substitute n value as 1. We will get it as n is 1. So it is cos 2 pi fct and n value is 2. So it is minus 1 by 3 cos 6 pi fct and so on. We are considering only first two terms for easily understanding. Next is 1 by 2 AC cos 2 pi fct plus 2 by pi into AC cos 2 pi fct into, again its equation is cos 2 pi fct minus 1 by 3 cos 6 pi fct and so on. Okay, now simplify this equation. So here the value is V2 is equal to 1 by 2 m of t plus 2 by pi m of t into cos 2 pi fct minus 2 by 3 pi into cos 6 pi fct plus AC by 2 into cos 2 pi fct plus AC by pi into cos square 2 pi fct. Next equation is cos square 2 pi fct. Next it is minus 2 by 3 pi into, so it is minus minus 2 by 3 pi into cos 2 pi fct cos 6 pi fct. So here m of t value will be there. Okay, so here I can write it this cos square theta as 1 plus cos 2 theta by 2. Now simply write this equation. Okay, so finally the value of V2 I can write as 1 by 2 m of t plus 2 by pi m of t into cos 2 pi fct minus 2 by 3 pi m of t cos 6 pi fct plus AC by 2 into cos 2 pi fct plus, here we can write the cos square theta as 1 plus cos 2 theta by 2. That is 1 plus cos 2 theta, here it is 2 pi fc. So 2 into 2 pi fct by 2. Okay, minus 2 by 3 pi into cos 2 pi fct cos 6 pi fct. So finally the value of V2 is equal to 1 by 2 m of t plus 2 by pi m of t cos 2 pi fct minus 2 by 3 pi m of t cos 6 pi fct plus AC by 2 into cos 2 pi fct plus AC by pi plus AC by 2 pi into cos, its value is 4 pi fct minus 2 by 3 pi into cos 2 pi fct into cos 6 pi fct. Okay, now this expression is passed through the band pass filter. Okay, now if you see what is the band pass filter frequency response is, the waveform will be like this. Here it is Fc and the 3 dB frequencies I can indicate as a lower sideband frequency and upper sideband frequency. Okay, so here the lower sideband frequency I can write it as Fc minus Fm, whereas the upper sideband frequency is Fc plus Fm. So from the given signal, what are the frequencies that are within the range of these LSB and USB? Those frequency signals are allowed and the other signal frequencies are filtered. Okay, which means it does not allowed. Now let us check which signal is passed through this band pass filter and which is rejected by the band pass filter. Okay, so here the first expression, it is having a signal that is m of t and its frequency as fm. So this is not allowed by the band pass filter since it is not in the range of fc plus fm and fc minus fm. Okay, now let us see the second signal. So m of t and cos 2 pi fct. So m of t, let us assume that it's having a signal frequency fm. So cos a, cos b, we can write it as cos of a plus b plus cos of a minus b. So here this having the frequencies that is fc plus or minus fm indicates it is allowed by the filter. So next let us see the third element. Here the frequency it is having a 6 pi, nothing but harmonics of a carrier signal. So it is rejected by the band pass filter. Now the next term is having a signal frequency that is Fc, which is allowed by the band pass filter. And here the next element, it is AC by pi, which is a DC component. As we know that the filter simply blocks the DC element, so it is not allowed by the band pass filter circuit. And here AC by 2 pi cos 4 by 4 pi fct, it is a harmonic of carrier signal. This will also rejected by the band pass filter, and finally this last term is also rejected by the band pass filter. Therefore the signal frequencies that are allowed or that are passed through the band pass filter is 2 by pi m of t cos 2 pi fct and AC by 2 cos 2 pi fct. Now let us write the expression of the output of a band pass filter, or I can easily write that as an amplitude modulated signal, that is output of a band pass filter. So which is equal to 2 by pi m of t cos 2 pi fct plus AC by 2 into cos 2 pi fct. Now simply take the common, that is AC by 2 into cos 2 pi fct. Okay, then its value is 1 plus 4 by, so here it is 1 by 4 by pi AC into m of t. Okay, now let us assume this AC by 2 as a signal or element, that is AC dash signal amplitude, and this 4 pi AC is nothing but some amplitude sensitivity factor which is indicated by a Ka. So finally I can write the output of a band pass filter expression as AC dash into cos 2 pi fct 1 plus Ka m of t. Hence, it is mathematically proved that by using a switching modulator also we can generate an amplitude modulated signal. This is the concept of amplitude modulated generated signal. Okay. Thank you so much. Keep supporting our channel by subscribing.